All right, so section 2.4, graphing two variable inequalities. So not graphing two different inequalities. We're going to be graphing one inequality, but it has two variables in it, right? X, Y. So that's what they mean by that, graphing two variable inequalities. Now, when we're doing this, there's a couple things you have to be aware of before we start the graphing process, okay? First off, our goal, let me put this right here. So our goal for this lesson is graphing inequalities by solving for slope-intercept form. Okay, this is what we need. We need to put them into slope-intercept form. Okay, once we have them in slope-intercept form, it's assumed that you guys are going to have no trouble graphing once it's in y equals to mx plus b. Now, in our case, it may not say y equals. It might say y less than, y greater than. Okay, so I guess just to be a little bit more specific, it could be this, 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 or that. Okay, any one of those four. Okay, it could be less than or equal to, greater than or equal to, but it has to have the y by itself, the mx plus b portion on the right side. Okay, so that's what we're looking for. Once we can get that, then usually the rest of the homework is easy. Okay, but getting it to that point could be difficult. Now, at first they're going to give you some problems where they're simple, but eventually you're going to have to do it the hard way. Now, before we get into graphing, like I said, I wanted to make sure you guys knew what we had to do. So make sure we solve for y. And then a couple of other things that you guys have to be aware of. Okay, so dashed or solid line. Okay, so when you're graphing it, should you graph a dashed line or a solid line? Okay, the way you know is like this. If it has less than or greater than, draw a dashed line. Okay, so your line is going to kind of look like this. Okay, if it's less than or equal to or greater than or equal to, draw a solid line. Okay, so that's one of the questions you're going to ask yourself. Should it be dashed or should it be solid when I'm doing the work? Okay, another question you have to ask yourself is, am I shading above the line that I drew or below the line that I drew? So let me put that right here, shading above or below. So above or below the line. Yeah, so above or below the line. So the way you're going to figure that out is actually depending on, again, your symbols. If it says greater than or equal to. So think about it. Greater kind of makes you think up, right? Something's greater, so it's above, right? So if it's greater than or equal to, shade above the line. Okay? So it doesn't matter what the line looks like. It could look like this. Sorry about that, the pen disconnected here. So your line can look like this. Maybe it looks like this, solid. You're shading above it, okay? So you're going to kind of like color above the line. Okay? So you're going to be coloring above it. All right? If you have a hard time understanding what's above, just pretend you have like a little marble and you drop it on top of the line. Wherever it hits and starts to roll, that's your above portion, right? So, but yeah, so greater than or equal to, greater, anything that says greater, so greater than or equal to, above, okay? If it says less than or equal to, you're going to shade below the line. And again, the line can look however it needs to look, but when you shade below it, it's going to be under it, okay? So when we do the work for today's lesson, there's not a lot of solve this, solve that. You are solving for a letter, but once you solve for that letter, you're just going to draw me a picture and color it in, and that is your answer. The picture is your answer. Okay, so make sure that your picture is right. There's no need to say x equals 7 or something like that. Now, there might be some cases near the end where we ask you, is this number part of the solution, etc. We'll talk about that in a bit once we start graphing, okay? So, again, just to reinforce what we just talked about, our main goal is to solve for y, okay? So we want it to be like an mx plus b format, okay? But it may not be equals. It's going to be less than or equal to, greater than or equal to. Once we solve, then we're going to have to graph it. So first we're going to start by graphing a line. So the question next is, should it be a solid line or a dashed line, right? So based on your inequality, less than or greater than is dashed, greater than or equal to, less than or equal to is solid. After you draw your line, then you got to say, how do I color it in? Above or below? Once we figure that out, then we color it in on our picture and we're done, okay? Those of you guys in ASB, I know you're supposed to leave at 8:45, so you can do that right now if you'd like. If you want to watch at least one example, it's up to you, but you're free to go if you have to. So, for all of these things, we're going to sketch the graph. Okay, we're going to sketch the graph. All right, so here's the first one. See you guys. So y is less than 1/5 x minus 3. Now they're going to give you a picture, okay? So let me go ahead and do that as well. So here's a quick picture of this. This is going by 1, so 1, 2, 3, 4, 5. 1, 2, 3, 4. I didn't make this one a square graph. I didn't need to. But, okay. So remember, our first step, our goal is to get it where it says y on one side. If you look, this is already done for us, so perfect. We got our equation, okay? Our next goal is to graph this inequality. Now remember, the way you graph it, if it's an mx plus b, you begin at your y-intercept, and then you move according to your slope, right? So where do I begin? What's my b value? -3. Thank you. What's my m value? 1/5. Thank you. So I'm going to start at -3 because that's where I'm supposed to begin on the y-axis. Here it is. There it is. There's my point at -3. And from that point, I'm going to use my slope to move, right? Move, since it's positive, I got to go up. 1 up, 5 over. So 1 up, 5 over, that's over here. Okay? All right, great. I got my 2 points. 2 points make a line. What kind of line should I draw if it says less than? You can look at your notes. Say again? Well, I don't need to know the direction, just what kind. Is this solid or dashed? Dashed, right? If look at your notes, it says less than, greater than, it's dashed line, right? So when I do this, I'm going to kind of draw like this. Okay, and then I'm going to take what Isaiah said. Which direction should I shade? He said down, right? Because less than is down, right? So I'm going to shade below. And this is my answer. I'm done with this problem. I'm not kidding when I tell you guys these problems are supposed to be easy. Like you just draw a picture. That's all you're doing. You're not really solving too much. Sometimes we are going to give you some problems where you're going to have to solve something. But we're not going to make you do like too many of those things. Any questions on this one? So remember, solve for y. First thing, figure out your y-intercept and your slope so you can graph it. When you're graphing it, you got to ask yourself, is it a dashed line or a solid line? That's the first question, because you got to draw it. And then you ask yourself, should I shade above or below? We shaded below because this says less than, right? It's right here, this thing right here, right? Less than. Since it says less than, I get to shade below. Okay, if it would have said greater than or equal to, I would have shaded above, right? And by the way, when you guys are doing this, notice how I fill my graph completely, right? I notice some people, when they draw me pictures, they draw a line and it's like this, right? Imagine if you're supposed to shade below, like, are you just going to shade like right here? Right? Like that's not right. It's a lot. It's a lot of information. So you got to keep going, right? You got to keep shading all the way because lines never end, okay? So your line should be like way out here like that, okay? Fill in the picture. Don't just do like a little small thing because that's actually not really correct. You want it to be the whole line, right? Fill the graph. So all right, let's do another one of these. Then we're going to do one where we have to kind of actually solve for something. So here's example number 2. So let's try y greater than or equal to negative 3x plus 2. By the way, some of these are going to be homework problems, some of them are not. The first one was a homework problem. Since these problems aren't too difficult to do, I don't want to do too many of them. Okay, I'd rather you get a little more practice than less. So y greater than or equal to negative 3x plus 2. Again, I'm going to draw a picture. So let me go ahead and do that. I'm going to draw a graph. One, two, three, 4. So this is a 4 by 4, so 4 to the right, 4 up. Kind of label those. Okay. So first thing you're supposed to do is solve for y. It's already solved for us, so we're good. Okay. Now, after that, we got to find our begin and our move, right? So what's my y-intercept, my b value? Positive 2. What's my slope? Negative 3, but that's not a fraction. Negative 3 over 1. Yeah, thank you. Over 1. So negative 3 over 1. That way we remember we got to move to the right, okay, not just down. So, all right, now we got our begin, our move. So we begin at positive 2. So here it is, positive 2 on the y-axis. And then we're going to move negative, that means down, 3 times 1 over. So 1, 2, 3, 1, that's right here. Okay? It's going to be a pretty steep graph, but it's okay. Should it be a solid line or a dashed line? Solid, right? Because it says greater than or equal to. So a nice solid line. And am I shading above or below? Notice it says greater than or equal to. Is that above or below? Above, right? Greater than or equal to, or greater than is shading up, right? Above. Above. So the above part would be here. Let me just kind of color that in. It's a lot easier when you have like a pencil. You can kind of just lay it on its side and shade it in. Bless you. think I told you guys that I like to draw. It's one of my hobbies. I'm not a great artist, but I like to draw. I like to doodle, right? So I remember when in high school when I used to do this, I used to draw my lines like really dark, and then just use my finger to kind of just like dust the shading area so it looked really nice and clean, right? So I just sometimes would kind of just start playing around with it. So I used to love math when it required graphing. I loved the math because I love to draw. So, but that was just something I used to do. Just kind of dust it real quick, right? Just smudge it and get my area there. And eventually I bought colored pencils, and it was a lot nicer using colored pencils. So, all right. So we good with that one? So not too bad, right? These questions aren't terrible, but of course they're going to make you do other stuff. So let me give you another example of the other stuff they're going to make you do with the same type of problem. Okay, we're not changing the directions. We're still just sketching a graph, but here we go. Something like this. So I'm picking this one because this one's kind of tricky. It's not that it's hard to do what we need to do, but there's a lot of little things you got to pay attention to. So I want to make sure you guys kind of see one like this. I'm going to make this one a 5x5. Yeah. All right, so let's see. 1, 2, 3, 4, 5. So there's a lot of little tricky things to this one, so I wanted to show you one that's like kind of weird. All right, so I cannot just start saying M and B are this because it's not solved yet, right? So I got to solve it for Y. So let's do that. 6x minus 5y is greater than or equal to negative 25. Now, if I'm going to solve for y, I need to get that x out of there, right? So let's subtract 6x on both sides. And I get negative 5y greater than or equal to negative 6x minus 25. Right, so all right, we're good so far. What's my next step? Divide by what? So if I divide by negative 5 and it's a greater than or equal to, what am I supposed to do? I think I'm hearing some people saying, I can hear the S's. What am I supposed to do with the greater than or equal to? Switch it, right? Anytime you're dealing with an inequality and you divide by a negative, you got to switch the inequality. So let me do the step here. Minus 5. So we get y less than or equal to, okay, less than or equal to, it switches 6/5 x plus 5. So there's a couple of reasons why I did this problem, okay? First reason, it wasn't solved for y. Second reason, you're going to divide everything by negatives, so you're going to have to flip inequalities. That still can happen. Don't forget about that, okay? Third reason, when we graph it and we follow the directions, it's not going to fit. So what do we do when the graph doesn't fit? We already did 2 problems where everything worked out fine, right? We put our b value and then we moved up and over or down and over, no problem. But what happens if I run out of room? So I wanted to do that just in case, right? So now that we see our equation, where do I begin? At 5, thank you. Where do I move? 6, and over 5. 6/5, right? 6/5. Now look at my graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, if I'm supposed to begin at positive 5, whoops, there's the news. Positive 5, Okay? I'm supposed to move which direction? Up, right? I'm supposed to move up 6 times and 5 times to the right. But look, I can't move up from that 5 6 more times and 5 times to the right. I can't do it. I'm out of room. Does anybody remember what we're supposed to do if we run out? Go ahead, Brandon. Hold on, let me get closer to you so I can hear you because the AC is a little loud. What is it? Kind of. Good. That's what we're looking for. You're going to do the opposite, right? Normally we're supposed to go up and to the right, but I ran out of room. So then I want to go down and to the left. Okay? You do the complete opposite. That way you don't have to like draw more graph. So I know we're supposed to go up 6, 5 times to the right, but since I'm going to run out of room, I'm going to do the complete opposite. Down 6 and 5 to the left. Okay? You will get the same answer, and right now I'll show you just to prove it. Okay? But you're going to get the same exact answer. So let's go down 6, 5 over. So 1, 2, 3, 4, 5, 6. That's going to be way out here. Okay? Right there. Now, just to prove to you, so Isaiah said, are we going to get the same answer? Check this out, okay? So, actually, that may not show up real easy. So this and this. Notice that's 6 units up, 5 units over. Right? So from the point on the left going to the point to the right, that's still 6 up, 5 over. So that means my slope is still being held true. I had to go backwards because I was going to run out of room. So if it tells you to go up and to the right and you're running out of room, then just go down and to the left. And that's how you'll fix it, okay? So you can see why I picked this problem, because if I would have given this to you, you'd be like, wait a minute, I can't draw anymore. Like, I must have done something wrong. No, it just means you ran out of room, but you can still work on it. Now, is this a solid or a dotted line? Solid, all right, so here we go. And am I shading above or below? It says, well, look at the y equal to, or y, the one we got. Less than or equal to, it says. So below, right? We're shading below for this one. Because of this. Once we solved it, I'm not looking at the original problem, because the original problem is not solved for y. I'm looking for the problem that's solved for y, right? So, and notice I am coloring all this stuff, and it can be annoying sometimes, but that's what you got to do. You got to color in your graph, okay? So that's why sometimes the smaller your graph you make, the easier. But ideally, you're looking for that. So it doesn't have to be perfect, but yeah, you want to make sure you kind of get all that little area there. Okay? Now, what exactly does the colored portion mean? Well, the colored portion is all of the solutions. In other words, any point found in that colored area, that shaded in area, any point is going to work. Let me kind of show that to you guys. Okay? So, let's take, for example, this right here, example number 2. Okay? Let's take example number 2, just as a way of showing you that this is true. So check this out. If I pick a point outside of the colored region, so let's say I pick the point -2, 1. Let's say I pick that point, -2, 1. Okay? And I plug that into my inequality. It should come out false. Okay? It should be a wrong answer. So let's try it out. If x is -2 and y is 1, so I'm plugging it into this equation, okay? That one right there. So 1 is greater than or equal to -3 times -2 plus 2. That means 1 is greater than or equal to 6 plus 2. So 1 is greater than or equal to 8. Is that true? Is 1 greater than or equal to 8? No, that point doesn't work. Why doesn't it work? Because it's not in the shaded region. Now let me pick a point that's in the shaded region. Let's try 3, 1. Let's try 3, 1. That's inside the little yellow colored region, right? Is that an answer to my problem? So I'm going to plug it in. So if I plug in 3, 1 into my equation, I'm going to get 1 greater than or equal to negative 3 times 3 plus 2. 1 is greater than or equal to negative 9 plus 2. So 1 is greater than or equal to negative 7. Is that true? Is 1 greater than or equal to negative 7? Yeah. So any point that you pick in the yellow region right there should come out to a true solution, a correct solution. Any point that you pick on the outside of it should come out false. Okay? So sometimes they ask you, is this point a solution to this problem? What they're asking you is the point they give you inside of the shaded region. So that's going to be the last example I give you guys today. It doesn't require any graphing. Example number 4. So, is the point, I don't know. Someone give me a point. Give me 2 numbers. Not too big. 1 and 4. Okay. Is the point 1, 4 a solution? And you know what? Let's even make it a negative 1. Let's make it a negative 1, 4, just to make something negative. So is the point negative 1, 4 a solution to, and I'll do this one. I'll do one of the harder questions, or harder looking questions for you guys. So negative absolute value of x minus 2 plus 3. They're saying, is it a solution to something like that? Don't worry, you're not going to be graphing any absolute values. They're just making you do it as a plug-in problem. Okay? So I'm going to plug in negative 1 for x. I'm going to plug in a 4 for y. So here we go. 4 is less than negative absolute value. And you know what? Let me change it to green just so it's a little bit more obvious that I'm about to plug in that number. Okay, so there's my x, y. I just plugged it in. And let's work it out. So 4 is less than negative absolute value of negative 3 plus 3. What's the absolute value of negative 3? A 3. So that's going to be minus a 3 plus 3. But notice there's still a negative in front of the absolute value. So that means it's going to transfer in. What's negative 3 plus 3? Say it again. 0. Thank you. Is 4 less than 0? No. This is false. So when they say, is the point negative 1, 4 a solution to that equation? You could say false, or else you can say, well, I put false because that's not true. I'm going to say not a solution. Okay, it's not an answer. So this is what your homework is like for today, guys.